Alright, so we're going to take a look at lesson number 8 today, and this is the last video of this series on exponential and logarithmic functions. Alright, so what we're going to look at is graphing logarithmic functions. With this first example, we have the graph of y is equal to log 3 of x that is shown. And in this graph, it passes through the points 3 and 1. Now, in each of the following, we want to complete the statement and sketch the graph on the grid. And we want to use the graphing calculator with this specific window format of -1, 11, 1, and my y window settings would be -4, 4, and 1. Now, if I were to graph, and this is what you should actually do, is input all of these into the graphing calculator, you'll come up with all the different lines that should be shown. Now, for this first one, if we wanted to graph log 10 of x, we would actually have to graph log x and then divide that by log 10. And we're going to get a graph after we adjust the window settings, of course. So x-min, we want it to be -1, 11, and 1. And then y-min, we wanted it to be -4, 4, and 1. All right, so it's going to look something like this. And yeah, and so the best way to actually draw these, rather than just drawing it randomly, so it just looks the same, the best way to actually draw these is to look at some of the values that are given. So at 10, it's going to cross at 1, and at 1, it's going to be at 0. Okay. Now, the reason it's good to look at these window settings is because we don't want to, get mixed up with which graph we're actually drawing here. And so, although there's still a little bit of randomness to my graph, it looks pretty similar to what y log 10 of x actually looks like. And if we look at where it passes through, we're passing through the point. When I'm at 1, I'm passing through 10 and 1. Now, next I'm working with log 1/3 x. If I were to go through and graph this, log 1/3 of x is going to look something like this. So I'm going to leave x there, but I'm just going to change the value of my argument here, which is going to be 1/3. Now, if you notice, it's going down now. My graph is opening down. And if we look at where the point passes through when y is equal to 1, it should pass when y is equal to 1. That should be down at, when y is 1. Should be at 1/3 actually, but I don't know. Can't find that value right now. It's showing as an error, but what we should have is y being equal to, or x being equal to 1/3. And so 1/3 and 1. And so if you notice what's happening, our base for our log is becoming the x-intercept. So here would be 1/10. Now in this next section, what we need to do is we need to name the domain and range for all of our graphs. Now the domains for all of these is going to be x is an element of real numbers. Because if you look at the graph, they open up everywhere. So every value of x is going to work on the graph. And the range is going to also be y as an element of real numbers. Now, the only thing with the domain with the domain, there are some limitations, right? because we have an asymptote, x has to be greater than 0. It's still an element of real numbers, but x has to be greater than 0 in all these cases. And the x-intercepts for all of them are going to be 1, 1, 1, 1. And the y-intercepts, since we have the asymptote at x equals 0, there is no y-intercept. So all of them, none. And the asymptote is going to be the same on all of them. Now the x value, not the x-intercept, like I think I mentioned up there, but the x value when y is equal to 1 is going to be the same as the base. So here's going to be 3, it'll be 10, 1/3, 1/10, and in this case it'll be b. Now let's see how, if we were to compare the graphs of y is equal to log 3 of x and log 1/3 of x, if we were to compare these graphs, we know that, well, if this had the point 3 and 1, and this one had the point of 1/3 and 1, this is actually a reflection in the x-axis. How do these graphs compare? Well, same thing. This would be at 10 and 1, and this would be at 1/10 and 1. So again, we're going to have a reflection in the x-axis. Now, if I were to compare the graph of y log 1b over x, this is, and the graph of y log b of x, again, just like up top, it's a reflection in the x-axis. Now think back to transformations like we did a few units ago, but in the last unit, in the transformation unit, the replacement for reflection in the x-axis is y go to negative y. Starting with y is equal to log b of x, we want to make this a replacement to determine the equation of the graph reflected in the x-axis. All right, so if I have y log b of x, and I want to go y is going to go to negative y, and if I input that into my function log b of x, this will then become, if I get rid of this y to the other side, this will become y is equal to negative log b of x. Now, we have two equations for the graph of y is equal to log b of x, so we could state it as y is equal to negative log b of x, or we could say that y is equal to log over 1 over b x. So let's look at this. If log 4, let's look at this as an equation. If log 4 of x is equal to 8, then the value of log 1/4 of x should then be negative 8, because if we have our value of 8 here, that's going to be reflected onto the opposite side, and we would get negative 8. Now we want to prove this by converting it to exponential form. All right, so if I have log 4 of x equal to 8, in exponential form, this statement would be x is equal to 4 to the power of 8. Now, if I were to solve log 1/4 x, and remember in lesson 5 we talked about setting our logarithmic function equal to v. This would then become x is equal to 1/4 the power of v, which is also equal to 4 to the negative v. Now, if I have my value of x here, and I know that x is equal to 4/8, or 4 to the power of 8, then 4 to the power of 8 is equal to 4 to the negative v. 8 would then be equal to negative v, or if I divide that by 1, v is equal to negative 8. Hence, log 1/4 x is equal to negative 8. All right, and you probably didn't see any of that, but here it is down here. So my value of x came into play right there. All right, let's look at part 2 now. So we have some partial graphs given to us. Now we have the partial graph of y equals log 2 of x, y equals log 4 of x, and y equals log 8 of x. And all three of those are shown. We want to complete the following statements. Y equals log 4 of x passes through the point 8 and 3/2. So if we look at where 8 is over here, 5, 6, 7, 8, and oh wait, that's not, 1, 2, 3, 4, 5, 6, 7, 8, and 3/2 right here. Y is equal to log 2 of x passes through the point 8 and 3. And then finally log 8 of x, that passes through the point of 8 and 1. The graph of y equals log 4 of x is a vertical stretch of the graph of y equals log 2 of x, and that's about the x-axis. State the stretch factor and complete the statement. Well, we have a stretch factor if we compare 4 and 2, so log 4 of x and log 2 of x here. If I was at 3 and now I'm at 3/2, that means we have a stretch factor of 1/2. So log 4 of x would then be half of log 2 of x. The graph of y equals log 8 of x is a vertical stretch of the graph of y equals log 2 of x. All right, so log 8 of x, I was at 1 and I'm at 3 over here. That means that the stretch factor is going to be 1/3 of log 8 of x, and so log 8 of x would be 1/3 of log 2 of x. Now use the results above to determine the transformation which would map the graph of y equals log 2 of x to the graph of y equals log 64 of x. All right, if we were to rearrange this, we could say that this is the same thing as, well, first of all, we would have a vertical stretch by 1/6. And the reason we know that is because 64 can be expressed as 2 to the power of x, if we're looking for our base 2 here. If I wanted to express this the other way around to get to 2, 64 to the 1/6 would equal 2. And so I know that it's going to be a vertical stretch by a factor of 1/6, and that is going to be about the x-axis. And so if I complete that statement, log 64x is equal to 1/6 log 2 of x. All right, so the general rule that we would apply here is that if our transformation maps y log b of x to y log b to the power of n of x, and it's a vertical stretch about the x-axis by a factor, it'll be by a factor of 1 over n, so that then log b n of x would be 1/n log b of x. All right, so that I know is a mouthful, but yeah, you might have to reread that just in order to get the gist there. Now describe the transformation which would map the graph of y log 3 of x to the graph of y log 81. Well, if I were to if we go 3 to the power of what, we want to know what which exponent that 3 is raised to, if that was a base, would equal 81. So 3 to the power of x is equal to 81. Well, 3 to the power of 4 is equal to 1. That would tell us that we have a stretch by a factor of 1/4. 16 and 4, well, 16 to the power of what is going to equal 4. That would be 16 to the 1/2 would equal 4, or square root of 16, and that would give us a factor of 2. And so if we just fill that in, log 81x would be 1/4 log 3 of x, and log 4 of x would be 2 log 16 of x.